So welcome for this talk. We're going to talk about how to leverage the Self-XSS. So as a one part of this talk, and then we'll see some novel attacks allowed through cookie tossing, which is a name which might not be really relatable at first, understandable. And I'll try to make it more clear through the talk. And so you will discover some new attacks that you might apply, that you might be able to apply for bug bounty programs if you are into it, and also potentially to protect yourself against these attacks if you are implementing something which is not to be attacked. Okay, so who am I? So my name is Thomas Houhou. I'm a bug bounty hunter. I've been hunting mainly for Swisscom for the Swisscom bug bounty program. I've reported around 60 vulnerabilities since 2021. That's kind of the program which got me started into bug bounty hunting. And then as I got a bit more confident, I decided to hack on other programs like X. I said more than 10 issues there. And then more recently, as I got interested into a bit more AI application security, LLM security, I recently sent vulnerabilities to OpenAI, into ChatGPT, and to Anthropic, so in Cloud. And I also reported other issues to Udemy, Twitch, USDOD, etc. And I also happen to be a student at ETH Zurich for the cybersecurity master. And so, that's about it. So let's dive into the content of this talk. What's cookie tossing? That's the very most important slide of this talk. So if you can understand it, that's great. So it just consists of abusing control over one subdomain in order to exploit other subdomains within the same company. So you just imagine a company which has, let's say, a domain company.com, that has many websites, and we assume that the attacker is able to control, and we will see which type of control is required for this attack, is able to control one subdomain, and from that, just interfere with the cookies which would be sent to other subdomains of the same company, so which share the same parent domain. So here is a short example. So we imagine the victim, who is the slot there, who visits the evilcompany.com, which is a subdomain that the attackers somehow control. And so that is the first step. In the second step, this subdomain would inject into the victim's browser some evil cookie. We'll clarify what these evil cookies really are later. And the important step required in this attack is the scope of the domain. And we particularly set the broad domain, so company.com, as the value for the domain. And as a result of this particular thing, whenever the victim would visit any domain, any other subdomain, so that shares any other websites that shares the same. Okay. Any other website that shares the same parent domain as the one that the attacker got, basically the victim would, when visiting this domain, send the evil cookies that the attacker sets. And so, that's about that's how this attack works basically. From that, there are no necessary vulnerability. That's purely anticipated by browsers, and nothing is dangerous so far. But we're going to see how to exploit this particular behavior to get some exploits. So how common and practical is that? So I mentioned that the subdomains require some sort of control from. Okay. So I mentioned that that this attack required some sort of control from the attacker on the subdomains. So you might wonder, and you might easily believe that you already have to compromise somehow the application, the company, to get this attack vector, but not really. That's actually more practical than that. And the first notice is that you don't need remote code execution or own the subdomain somehow to get this attack. The easiest thing that you would need is arbitrary JavaScript code execution. So you can think about just XSS to achieve it. And so there are two ways to get cookie tossing, where the first one is cookie tossing by design, which actually consists of all companies which allow their customer natively by as they wish it to have a specific subdomain on their particular application. So a very common case of that is the blogging platforms, the website builders. So you may think about Weebly, Squarespace, MyShopify. So in these particular instances, it is wanted actually, and it is by design that the user somehow controls a particular subdomain of this company. Then you also have the platform as a service. You have Heroku, Bubble, and yeah. And also interesting case, is the case of telecom providers. So, for instance, Swisscom, it has for all customers or for some customers, these particular, domains which are given to them. So, customer ip.cust.swisscom.ch. And so any customer from Swisscom would be able to have control over a subdomain which is under the same parent domain as other potentially critical Swisscom applications. And so cust.swisscom.ch is the most well-known one and the most advertised on X by Antoine. But there are actually other ones which are actually also included in the out-of-scope list for Swisscom. We'll come back to the out-of-scope elements. You want to say something?
Yeah, I just wanted to say that thanks to you, it's not the case anymore.
Oh, okay.
The customers now, if you're a Swisscom customer, even with mobile, you can check your reverse DNS from your IP. You will see it's not .ch anymore. So,
oh, okay, great.
So,
okay. Okay, so yeah, so you can't use the cust swisscom.ch gadget anymore, but there are other maybe
wingo.ch.
Okay, so you can still use cust.wingo.ch and ernasdin.bluein.ch, and maybe there are other ones like you just have also to do reconnaissance to discover them. They are not always as obvious as this one, and so that's this first option when you just need to discover something that are allowed by design by default for the applications, and that allow you to control these subdomains. So that's the easiest case. In the second option, where you have not, where you have the application you want to target, isn't really, associated to these, kind of things, you have to find a vulnerability. And in this case, the three vulnerabilities of interest will be obviously, remote code execution, since you can do, any of the below. Then you have HTTP response splitting, where you are actually able to control the HTTP response that the web server is going to send you, to send to the victim. So by controlling the response, you can inject the cookie that you want. And you finally have XSS, since you can, through JavaScript, you can manipulate the cookie jar of the victim. So you can do something like document.cookie equal, etc. to just inject cookies. And so now, how to get XSS, kind of easily. The easiest way is just to, abuse of file upload on CDN subdomains. And, a common case for that is the XSS via upload of SVG file. If the company doesn't really care about some sort of thing, and your upload would likely go into a CDN subdomain, and the company might put it as out of scope, but you would still have the gadgets for the cookie testing. And so that was for the manual part to find XSS quite rapidly. So there are still other ways, obviously. But, and so if you want also an automatic solutions, you could just use nuclei and find, easy to find XSS on subdomains, maybe that the company wasn't aware of in the first place. So these are the two options to get cookie testing. And so now let's briefly mention the out-of-scope subdomains. So, a very good place to start if you are hunting on a program, to discover the two options is just to actually look at the subdomains that the company mark itself as out of scope. And that's the classic example of Swisscom, where cust.swisscom.ch is highly advertised as, so it used to be highly advertised, and that's not even the current bio of Antoine. It used to be advertised as, the thing to avoid, but, actually, it should really be seen with more nuanced. And even though it's not a target, which is recognized by the bug bounty program and on which you will get paid, you should just see it as a way to get some cookie testing gadgets or other gadgets. So looking at the out-of-scope subdomain is a really good way to start. So now let's dive into the first step. So the first attack and exploitation method allowed via cookie testing, which is turning self-XSS into a high-impact vulnerability. And so there are kind of three ways to see the self-XSS. So at the beginning, you might not recognize the difference and consider the difference between self-XSS and a true XSS that actually applies to victim, to another user. So you might just want to report it straight away and thinking that you find some sort of JavaScript execution. And actually here, I'm not even considering like the JavaScript code execution that you would just copy paste into your dev tool. Like this one is obviously not a bug anyway. And when mentioning self-XSS in this talk, I will only refer to code that only gets executed, like that can't get spreaded to another user different than you. Basically, we'll come back to that later. And then you might think that, so you might have some troubles with bug bounty program not accepting your reports about self-XSS. So you might become a bit skeptic and cynic about self-XSS and just think that it's not worth your time and it's just out of scope. But actually, then you might want to try to find ways to exploit it, because there are many ways through computer scene mainly. So, let's briefly mention the multiple shades of XSS. So there are three kind of instances of XSS, even though depending on what you put behind these words, you might only have two, reflected XSS and stored XSS. But, so basically reflected XSS is the ability, is like the reflection of the payload from an HTTP request to the immediate HTTP response. And so you would have some, JavaScript code injected into the HTTP response, and you would be able so which would reflect, hence the name, and you would be able to get JavaScript code execution from that. So this is a non-persistent XSS. Then you have the persistent XSS, also called stored XSS, where you don't need, like you can just poison a particular endpoint through a JavaScript payload, and then it would get triggered later on in the future by someone. So it would get stored permanently in the page. And then you have the DOM XSS, where you don't really rely on on the code getting stored in the HTTP response, but rather on its execution by some JavaScript functions. After the DOM, like as the page gets rendered. So self-XSS in this picture is just an XSS that can only get triggered within the attendance session. So you actually have an injection somewhere, you actually have some sort of beginning of vulnerability, but you are not able to spread it to any other users, so that's useless. So some features that you can think of are private mode features, post preview that can only be seen by the author, so you are not able to send it to anyone. And so that what makes many bug bounty programs believe that this issue is not worth a report. And so the Amazon bug bounty program and Uber bug bounty program, for instance, both put it as out of scope, and it's the case of many programs actually. So yeah, no one really cares about them. So now the classical way that you might have heard of if you ever tried to exploit self-XSS is to combine it with a cross-site request forgery, which is CSRF. And CSRF is a vulnerability, so it's another vulnerability where you're actually forcing a victim into doing a particular action. So if you are both able to force a victim into doing a particular action, and if you have an endpoint where you are able to trigger some code that would only get triggered for the person doing this action, you can combine these two to force the victim into putting in its own account the payload, and so you would be able to leverage it through that. But so that's the most known way to exploit it, maybe. But that's actually not really not that plausible anymore, and not that trivial to find these two together, since modern framework protections make CSRF tokens way easier to implement straightforwardly. And even if you kind of find an endpoint which doesn't have CSRF token, you might just get annoyed by the browser cookie policy if the session token was set with a particular strict same site policy, since you wouldn't be able to have the victim send the session token in a cross domain request. So you would still get cancelled in your attack through the security. So yeah, you actually need another strategy, and we'll come to that now. But before, let's mention briefly the same origin policy, whose goal is to isolate websites of different origin by restricting the capabilities of JavaScript. And so it basically make it so that websites of different origin cannot read the cookies of each other, cannot read the local storage of each other, and cannot send a particular request to the other website and read the response back. So that's a very critical thing. And cannot read the DOM/content of the page. So for instance, if your website, like if you have attacker.com, it can't just open as an iframe gmail.com and read the content. Otherwise, that would be kind of problematic. And so yeah. And why I'm mentioning this is because on the opposite way, and that's the very important part, if you are able to be on same origin, any of the above becomes possible. And so you have lots of capabilities for your JavaScript code. So now we can go to the changing perspective on Self-XSS, given the power that JavaScript code has on same origin. And the basic statement of this slide and maybe of this talk is that XSS is more about an origin problem than a session problem. You don't really care about the victim being authenticated as his own account when triggering the payload, but what you care actually more is the victim being on same origin when triggering that payload. So actually, instead of wanting the victim to be authenticated as itself and just think that Self-XSS is not propagatable to another victim because the victim wouldn't just be able to see it, you might actually just want the victim to be authenticated as the attacker, so who is the one who is able to see the payload and to trigger the payload, and then benefit from the same origin capabilities that this JavaScript code would have. So yeah, we just want the victim to be authenticated as the attacker, and the assumption related to that is that as long as arbitrary JavaScript code is executed within the same origin, we can figure out a way to affect the victim, even if for that particular endpoint where the code triggers, the victim is not authenticated as the victim. We'll see what this is really about. So, how to force the victim to authenticate as the attacker? We use cookie losing there. And the twist of this thing is that we only authenticate the victim as the attacker on a specific path on the application. So the application has many endpoints, and you just authenticate the victim on the endpoint precisely where the where the XSS triggers. And also, yeah. So, the victim would, first visit evil.company.com, then evil.company.com would inject into the victim's browser, a session token. So this is the session token of the attacker. So this is, in this particular case, for Self-XSS, the evil cookie that we mentioned earlier. And, still for the scope, company.com, so that it can apply to all of the subdomains of the same company. And, so the difference between before is that we set now the path parameter, which is, only the path of the Self-XSS. So this cookie of the attacker, the session token of the attacker, makes it so that the victim would only be authenticated as the attacker on the particular endpoint of the application where the Self-XSS triggers. So now as a result, if the victim tries to visit so any other subdomains with, for instance, the broad path / then everything would be fine. The victim would be authenticated as the victim, since the cookie injected by the attacker would not apply there due to the path. But whenever the victim would visit a subdomain through the appropriate path, so where the cookie was injected, then it would actually send the cookie of the attacker, so which was injected. So that is very the essence of this attack, the main idea. Okay, and so now let's mention the general attack scenario to leverage Self-XSS via cookie tossing. So first, we have the victim. I don't know if you can see it clearly. Is it fine? Okay. The victim first visits the evil or vulnerable subdomain, so to get cookie tossing. We get the cookie tossing gadget which triggers. The cookie of the attacker is set on the whole domain, so for the scope company.com. But only for the specific path of the XSS. So you have what it would lead. It would be like that in JavaScript. Then the victim is redirected to the Self-XSS trigger endpoint. So in the first step, the victim is on the website controlled by the attacker, and then this website just redirects the victim to another website on the second step. And so in this case, the victim would then be redirected to the particular endpoint where the Self-XSS of the attacker triggered. And since the victim is authenticated as the attacker for this endpoint only, then the victim would actually get the payload which triggers in its own browser. And now we're actually able to have the victim have arbitrary JavaScript code, so malicious JavaScript code executed on a particular critical application, while the victim is on the same origin as all other critical endpoints, where the victim is authenticated as the victim, so as themselves. And so now we can get to the third step, which is pivoting. So the nodes in green are all the endpoints where. Okay. So the nodes in green are all the endpoints where the victim is authenticated as theirself, so as the victim, so where everything is fine. And in red is a particular endpoint where the victim is authenticated as the attacker, so where the website led the victim to after the redirection. And so now we are at the step of pivoting, which is the actual exploitation of this attack. And what we want, so remember the capabilities that JavaScript code has when on same origin. And so for instance, if there is an endpoint API/key, what this JavaScript code can do, benefiting from the same origin policy when on same origin, it can basically request this endpoint and read the response back. So that's the first way to exfiltrate some data from that. And then it can, of course, exfiltrate the data back to the server of the attacker by making another request. And for instance, if there is another endpoint, for instance, account/change password, this JavaScript code is also able to trigger this change password feature and replace the password of the victim with another one. And so you would kind of achieve the same impact of a CSRF in this case, except that you are not doing any cross-domain requests. You're still on the same origin. But these are some main ways to pivot. Okay, so now let's see the first case study of that, which is exploiting Jupyter Hub. So Jupyter Hub is a project from the project Jupyter, which so the Jupyter notebooks, etc., which is a multi-user platform that allows users to run Jupyter notebooks on a shared server. So that's very popular in universities or in companies, mostly doing machine learning. And so the most common implementation for Jupyter Hub is the single domain hub. So you would have many users, each having their own workspace, but interacting on the same domain. So same domain and same subdomain, hence the name. And so the main thing to remember from that implementation is that every users are on the same origin. Then the second ingredient for the exploit is that we have a self-XSS by design for Jupyter notebooks, since each cell can contain JavaScript code. And so through the syntax %/%gs, you can below this inject anything you want, and it would get triggered automatically. So if you create a notebook which contains this code, you can then save this notebook. You would have a clean URL. So for instance, if you name it self-XSS, if you name your notebook self-XSS, you would get this sort of URL. And whenever the victim or whenever you would visit this URL, this notebook would automatically trigger. So you would get this JavaScript code execution directly. And so yeah, that's still at the self stage now, because it is the attacker's responsibility to create this notebook. And so in the next step, we actually want the victim to kind of see it, right? So this brings us again to cookie tossing. And since like Jupyter Hub is an open source project that can be implemented by everyone, we kind of assume that it exists. So for instance, that was the case of ETH. For instance, the Jupyter Hub was hosted on the subdomain, so studentjupyter.inf.ethg.ch for my project at least. So there might be many other ones. And for instance, the ethg.ch hosts many other trashy subdomains, which I call it like that because they are insecure, in the sense that there is also another subdomain, which is blog.eth.ch, which allows any student to write a blog for themselves, and so to potentially inject any arbitrary JavaScript code there. So that would be an example of gadget for ETHZ. But yeah, since this project is widely deployed, you can assume that cookie tossing will exist, or like for a specific percentage at least. So now the final ingredient, which is pivoting. We know how to make the victim visit our self-XSS trigger endpoint through cookie tossing. We have this self-XSS endpoint through the native feature allowed by notebooks. And now we want to know, we want to know what we are going to do whenever the victim would get this code triggered in the attacker's notebook. And so that brings us to the pivoting part, which is, and so in this particular case, for Jupyter, whenever visiting the workspace's endpoint, the token, so the session token directly would be included in the response. So, we can now get our full chain. So, the one-click account takeover on Jupyter Hub. So we first do, the cookie tossing part. So the cookie is authenticated as the attacker just for the part, just for the endpoint related to the notebook, to the poison notebook. Then the trigger, so the victim then triggers the attacker's self-XSS by being redirected to it. And finally, we get to the pivoting part. And so the JavaScript code requests this workspace endpoint, which was seen. And so for the username of the victim, like in the URL, that's just this thing to consider. So the attacker needs to know the username of the victim. And so, this particular endpoint would just fetch, the workspace endpoint of the victim. And since it's on same origin, we benefit from the same origin capability of this code. And, we are able to extract the session token of the victim. So, yeah, so that led to this particular CVE assigned by Jupyter Hub. Okay, so now the second case study, which is Swisscom MyCloud, which is another instance of one-click account takeover, which was allowed by cookie tossing. So we also now try again to collect our ingredients. So we get a self-XSS on this particular subdomain, which has been fixed now. And so, yeah, we get this thing, which is injectable into this screenshot, but it can only be triggered on the side of the attacker, as before. Then, we get the cookie tossing by design in this case. It's not self-XSS by design as Jupyter Hub did, but cookie tossing by design. And we actually, in this case, relied on the cust.swisscom.ch domain, but that's fixed apparently. So, so, yeah. And so you basically have this cookie tossing by design there. So you just have to find XSS on one of the Swisscom customers. And, so yeah, you can find it easily through Nuclei because like that's, customers, they are not really secure. Like they don't really care. They are just hosting anything they want on these subdomains. And so that's very, very often prone to vulnerability. In this case, like you might also have found like RC very easily. And, finally, the pivoting stage. Actually, in this case, you don't even need to get like another endpoint which leaks data. You can just rely on the cookie, since the MyCloud login token, which is the session token associated to MyCloud, directly contains the access token and is not protected through HTTP only. So you might just make the victim visit the I don't know if I showed it. Yeah, you might just make the victim visit the endpoint where the code triggers, and instead of just pivoting like to somewhere else, so to another endpoint, you can just retrieve the cookie. And so that's what this payload did. Okay, so now novel attacks via cookie tossing. So we're going to see. So that's me who personally coined this term. Like I don't own specific ownership about this term. So you can use other terms if you want. But yeah, that's just an easy way to name them. So we're going to talk about multi-step process hijacking and targeted action poisoning, and so which are two other possible things which can be done through cookie tossing. So multi-step process hijacking. So first, we're going to see what's a multi-step process. What I really mean by that. You can just see it as an action that involves a specific sequence of HTTP requests and responses. So for instance, user account sign-up process is usually seen as a multi-step process. You would first have an HTTP request, which would specify the full name, address, phone number, etc., or maybe other information. Then, so the server would get into a particular state. Then you send the second request where you specify your email address and password. The server would again get into a new state, and finally you specify you verify your phone number. So after the server sends you a specific verification code on the second step, and now you are done. Your account is actually created. So sorry, that's not really beautiful, but yeah, you can see it like that again. So in these three steps, it's just like doing one action, which is the account sign up, but split it into three different requests, and for which the server has to keep track of the state of the user, where the user is at. Okay, and so now the notion of state and substate, just rapidly. So the state can be seen as the naive binary thing. The user is registered, the user is not registered, and the substate is a more fine-grained thing, which keeps track of where the user is at for the whole, multi-step process. So for instance, the user could store the internal substate related to a user flow, which could be user provided full name, address, and phone number, but not yet email and password. So after the first step, nor verify the phone number, obviously. As a second substate, you could have the user provided email, password, and prior info, but didn't verify the phone number. And yeah, that is all the intermediary states, basically. Now, about the shortcut on preserving consistency. So this is directly related to the notion of state and substate. So why do you want to keep track of state and substate? It's because you don't want the user to be able to shortcut the process, to go from step 1 to step 4, even more if the process is critical somehow. For instance, you can think about 2FA. You don't want the user to skip directly after the 2FA, after providing the password. And you also want to preserve consistency. So to ensure that you are returning to the user the correct HTTP response, which needs to be sent at this right time. And so for that, that's the notion. Yeah, so that's where and that's how and why the server is very required to keep track of the user substate as it goes through the multi-step process. So after step 1, you have a specific substate. After step 2, you have another specific substate on the server, and so on and so on. And how to do that? So if the user is already authenticated, then that's not that hard. What you can do is just correlate the substate of a user on a particular process through directly his user ID, which is provided through the session token. So you could just say that user X is at step N of process Y. So you would just have a structure which encodes it on the backend. And the problem goes actually where the user is not authenticated. And for that, so if the user is not authenticated, you don't really have a way to keep track of the user directly and to correlate things directly through the user ID. And so, how much time do we have left? Oh, okay. I'll try. Okay. How much time can I go? 2 minutes? Oh, okay. Okay, let's go to the attack. Okay, so there is another way to keep the states, which is through cookie. And so you basically get an identifier for the cookie, and you assign to a structure on the backend. I don't know if it's going to be possible to do it that fast. But so basically, so the attack is when the server doesn't assign a new state cookie to the user at each new step. And so the attack is that you want to inject, as the attacker, your state cookie into the victim's browser. Then the victim does a particular action on the multi-step process, which would upgrade the state of the cookie on the server, but not on the client. So the attacker would be able to jump back to hijack the flow and to through his own state cookie that he knows of, to continue the flow. And so, I directly go to this step. Maybe it will be clearer, maybe. So, okay, so you have the Swisscom login process, which is, submit username, submit password. If 2FA, then you have the 2FA challenge, or not, you can set it up. And so in this particular case, you would want to inject the cookie, at the very beginning of the process, let the victim submit the username and password. And in the particular case where the 2FA triggers, the attacker would be able to jump right there because the state cookie didn't evolve. I don't know if it's clear, but yeah. And I won't really have the time to go further on that. And so, there is specific detection methodology related to that. Then there is another, so now we can talk pretty rapidly about, target detection poisoning, which is roughly the same idea of the tree, as related to self-XSS. So you authenticate the victim just on one part, but in this case, you don't want to do any pivoting. You don't want the victim to trigger any JavaScript code, but you just want the victim to submit a specific data. So for instance, if you have an application with, which allows you to add credit card, you would want the victim to just make it so, to just on the specific endpoint where the credit card should be added, to submit it under the attacker session, under the victim session. And since you only fixated for a specific endpoint, the victim would not have any way on the user interface to be aware that he is authenticated as the attacker, not as the victim for this particular endpoint. And so I directly show you a video logs. So I don't know if you know perplexity. No, I won't have time for the video. Yeah, so basically the detection methodology is that you identify an action which leads to the submission of sensitive data, and for which session token swapping, which means that you inject the session token of the attacker for this particular endpoint only, and so you want the action to be still functional. You don't want the victim to crash on this particular endpoint, and you want no reference of the attacker session on the victim UI. This particular thing is just to make the victim not aware that he's actually logged in, authenticated as the attacker on this particular endpoint. You want really no clue. You want really the victim to be really unaware of this particular fact, and just to submit data and see no problem in that. And why it would be actually under the hood submitted under the attacker session. So I don't know if it was clear. And so conclusion takeaway. So Autoscope can be seen as a gadget provider, not as a target. So for cookie tracing, that's very useful. Self-XSS often has unrealized potential. You can do many things with that, and it's really a shame to report it straight away or just to sit on it. You can actually really do many things with that. Pay attention to how applications might end states in multi-step process to potentially exploit the multi-step process hijacking. And when dealing with actions submitting sensitive data, check if it can be poisoned. And so yeah, the general idea of this talk is cookie tracing that opens the door to many attacks and to other attacks that I didn't even mention in this talk. And so to dive deeper, to see things that I didn't have the time to mention and too rapidly maybe, you could actually just check this blog that I did, which basically writes in a more comprehensive way what I just told. And you can also check the research of another security researcher, which was one of the first to mention cookie tracing and the other attacks, which is File Descriptor. Not really active nowadays, but you can still see the previous talks and blogs, etc. So thank you.